Good morning.
Good morning.
Teleportation has finally become a reality. Finally, Google scientists have successfully created the world's smallest shortcut, a wormhole, using a quantum computer. Moreover, they have successfully teleported a particle from this wormhole. But wait a minute, how did this happen? I mean, we all know the concept of wormholes. Wormholes. If you want to travel from point A to point B, a wormhole can be created to bridge the distance. However, there's a vast difference between folding a piece of paper and bending the fabric of real space-time. This is why the concept of a wormhole in the space-time fabric has been a topic of controversy for decades. Few people know that the concept of the wormhole was born out of controversy. When Einstein first introduced the idea, it was intended to challenge and disprove quantum mechanics. Our journey begins, as so many scientific journeys do, with Albert Einstein. In the early 20th century, Einstein revolutionized our understanding of gravity with his theory of general relativity. This groundbreaking theory painted a picture of the universe where gravity is not a force acting at a distance, but rather a curvature in the very fabric of space and time. Imagine a bowling ball placed on a trampoline, causing the fabric to sag. That's how Einstein envisioned massive objects warping the space-time around them. While general relativity elegantly described the universe on the grand scale of stars and galaxies, it clashed with the emerging field of quantum mechanics, which sought to explain the universe on the subatomic level. Quantum mechanics revealed a world of fuzziness and uncertainty, where particles could exist in multiple states at once, and where the act of observation could influence the outcome of an experiment. Einstein, famously skeptical of the probabilistic nature of quantum mechanics, spent much of his later years searching for a unified theory that could reconcile these two seemingly incompatible views of the universe. Among the many strange and wonderful predictions to emerge from his theories was the concept of wormholes, theoretical tunnels that could connect distant points in space-time, allowing for shortcuts across the vast cosmic ocean. Imagine folding a piece of paper in half and then poking a hole through both layers. That hole, in essence, is a two-dimensional representation of a wormhole. It creates a shortcut, allowing you to travel from one point on the paper to another without traversing the distance across the surface. In the vast expanse of space-time, wormholes are thought to function similarly, connecting distant regions of the cosmos through tunnels that bypass the conventional limitations of space and time. These cosmic shortcuts arise from the mind-bending mathematics of Einstein's equations, which allow for the possibility of space-time being warped and twisted in ways that defy our everyday intuition. Picture the universe as a giant rubber sheet. A massive object like a star creates a deep well or indentation in this sheet. Now, imagine that two such wells are brought close enough together that their sides touch. A tunnel or wormhole could form, connecting these two distant points in space-time. This is where Google's groundbreaking experiment enters the picture. Using a cutting-edge quantum computer known as Sycamore, a team of researchers led by physicist Maria Spiropoulou claims to have created a system that exhibits all the hallmarks of a traversable wormhole. Their experiment involved manipulating pairs of entangled particles, which are linked in such a way that they share the same fate, no matter how far apart they are separated. By entangling these particles and then sending one through a highly controlled quantum circuit, the researchers observed a signal that emerged from the other side, as if it had traveled through a shortcut in space-time. This breakthrough has sent shockwaves through the scientific community, with many experts hailing it as a major milestone in our understanding of quantum gravity and the nature of space-time itself. To truly appreciate the significance of Google's achievement, we need to delve a little deeper into the intricacies of their experiment. The researchers utilized a concept known as quantum teleportation, a phenomenon that has been experimentally demonstrated before, but never in a way that so closely mimics the behavior of a wormhole. Imagine you have two coins, each hidden under a cup. You and a friend each take one cup, and without looking at the coin beneath it, you move far apart. If you then lift your cup and see heads, you instantly know that your friend's coin must be tails, even though they haven't looked at it yet. In Google's experiment, they entangled two qubits, the quantum equivalent of bits in a classical computer. What they found was that the information encoded in the first qubit seemed to reappear in the second qubit, as if it had traveled through a shortcut in space-time. The implications of this experiment extend far beyond the realm of theoretical physics. If we can create and manipulate wormholes, even on a microscopic scale, it could revolutionize our understanding of the universe and our place within it. One of the most tantalizing possibilities is the potential to study the universe's earliest moments. Currently, our understanding of the Big Bang only goes back to a tiny fraction of a second after the event itself. The very early universe was so hot and dense that light couldn't escape, creating a barrier beyond which we cannot see with conventional telescopes. However, wormholes could potentially offer a way to bypass this barrier. If we could create a wormhole that stretches back to the universe's infancy, we could potentially observe the Big Bang directly, unlocking secrets about the universe's origins that have remained hidden for billions of years. Google's experiment has also injected a much-needed dose of excitement into the field of theoretical physics. For decades, physicists have been grappling with the challenge of unifying general relativity and quantum mechanics into a single, coherent theory of quantum gravity. This elusive theory would provide a complete description of the universe, from the smallest subatomic particles to the largest cosmic structures. While numerous theories have been proposed, from string theory to loop quantum gravity, none have yet been experimentally verified. Google's artificial wormhole could provide the first tangible link between these two seemingly disparate realms of physics. This could have profound implications for our understanding of the universe's fundamental nature, potentially opening up new avenues of research and leading to the development of entirely new theoretical frameworks. Despite the excitement surrounding Google's announcement, it's important to approach these findings with a healthy dose of scientific skepticism. The experiment, while groundbreaking, is still in its early stages, and further research is needed to confirm the results and rule out alternative explanations. Some critics argue that the observed signal could be due to other quantum phenomena, not necessarily a wormhole. They emphasize the importance of replicating the experiment and conducting further tests to solidify the claims. This skepticism is not a sign of doubt, but rather a testament to the rigorous process of scientific inquiry. Extraordinary claims require extraordinary evidence, and the scientific community is right to demand thorough scrutiny of such a potentially paradigm-shifting discovery. While it's still too early to say definitively whether Google has indeed created an artificial wormhole, the very possibility opens up a Pandora's box of potential implications. If we can harness the power of wormholes, it could revolutionize space travel, communication, and even our understanding of time itself. Imagine a future where spacecraft could zip across the vast distances of interstellar space by taking shortcuts through wormholes, eliminating the limitations imposed by the speed of light. Such a feat would render the universe a much smaller place, allowing us to explore distant star systems and search for extraterrestrial life with unprecedented ease. Wormholes could also revolutionize communication, allowing for instantaneous transmission of information across vast cosmic distances. This would have profound implications for our understanding of the universe and our ability to communicate with potential alien civilizations. Perhaps the most mind-boggling implication of wormhole technology is the possibility of time travel. While the concept has long been relegated to the realm of science fiction, some physicists believe that wormholes could potentially allow for journeys through time, albeit with numerous caveats and paradoxes to consider. Imagine a wormhole that connects not just 2 points in space, but 2 points in time as well. By traveling through such a wormhole, one could theoretically journey to the past or the future, altering the course of history or catching a glimpse of what's to come. Beyond time travel, wormholes could also pave the way for teleportation, allowing for instantaneous transport of matter from one location to another without traversing the physical space in between. While such technology may seem like pure fantasy, the principles behind it are not entirely outside the realm of possibility, at least in the theoretical realm. Google's purported creation of an artificial wormhole, while still shrouded in uncertainty and debate, stands as a testament to the boundless potential of human ingenuity and our insatiable curiosity about the universe we inhabit. It serves as a powerful reminder that the cosmos is full of mysteries waiting to be unraveled, and that the pursuit of knowledge is a journey without end. Whether or not this experiment ultimately proves to be the breakthrough it promises to be, it has undoubtedly ignited our collective imagination, reminding us that the universe is a far stranger and more wondrous place than we could ever have imagined. As we stand on the cusp of these groundbreaking discoveries, one thing is certain: the quest to understand the cosmos is an endeavor worthy of our greatest efforts. The journey ahead is sure to be filled with challenges, setbacks, and perhaps even more questions than answers. But as we venture further into the unknown, guided by the light of scientific inquiry and the spirit of exploration, we can be certain that the universe will continue to surprise and amaze us with its infinite possibilities.